Okay guys, so today, here's what we're going to talk about. We're going to talk about special products of polynomials. Basically what this means is we're going to keep looking at what happens when you multiply two polynomials together. What's going to be different today is we're going to look for some patterns. We're going to look for some shortcuts to see if there might be some ways to kind of save ourselves some time, save ourselves some work, so that when we recognize kind of these special cases, they don't take us near as long as far as multiplying them out, and we'll look for kind of those shortcuts. But here's what I want for you to do. At this point, you see those examples where we've got at the far left x minus 5x plus 5, and then we've got x minus 2x plus 2, and then x minus 12x plus 12, and then x minus 4x plus 4. What I would like for you to do right now is to go ahead and just multiply each one of those out. I'm going to show it to you in a little bit, but for right now, I want you to pause the video, use either the box method or use regular old distributing, and see what you get for your answers. If you get done with that, and before I go through them, if you've already noticed a pattern, you might write down what that is. We're not actually ever going to talk about that in this video. We will talk about it possibly on Monday, but I really want for you to find it on your own, so no guarantees there. I will at least show you how to work these problems, but right now, go ahead, pause the video, and we will look at them in just a little bit. All right, let's go ahead and take a look at this first example where we have x minus 5x plus 5. First thing you want to make sure and do, take x, multiply by x, should get x to the power of 2. Then take x, multiply by 5, you get 5x, and I'm going to try to make this a little bit bigger, maybe a little easier to see. There we go, 5x there. Go ahead and change up some of these other ones, make those lines a little bit easier to see. So the first thing we did was take x, multiply by x to get x squared, then took x, multiplied by 5, gave us this 5x. Now we're going to go back through and distribute negative 5. So negative 5 times x, we get a negative 5x, negative 5 multiplied by 5, you get a negative 25. Now, here's the thing to look for, is in the middle, there should be a couple terms that you can combine together. If you take a look here, 5x and negative 5x, if I take 5 minus 5, technically what I have is 0x. But instead of writing 0x, here's what we do instead, is we say that they cancel each other out, and they would be gone. In other words, 5x and negative 5x added to be 0, they're gone. The only things you're left with is this x squared that's out in front, so we bring that down, and this negative 25 that's at the end, and so we bring that down as well. And so then for your final answer, you're left with just x squared minus 25. All right, let's take a look at the second example now, which is going to work kind of similar. You've got a minus 2 multiplied by a plus 2, and when you went and multiplied here, you took a multiplied by a, gave you a squared, a multiplied by a positive 2, you got a plus 2a, and then you went and distributed a negative 2. So you did negative 2 multiplied by a was a negative 2a, negative 2 multiplied by 2 was a negative 4. And then once again, watch what happens. In the middle, where we should be able to combine some stuff, we've got positive 2a minus 2a is going to add to be 0. And so then what you're left with is you bring down your a squared that was out in front, bring down your minus 4, which was your last term, and there's your final answer, a squared minus 4. At this point, this would be another good chance for you to pause the video and look and see if you can find any similarities between the two problems. Look for any differences as well. All right, we're going to take a look at two more examples to see if you can kind of spot the pattern. If you think you already know what the pattern is, maybe check yourself on these two and see if it actually holds. I'm going to go ahead and work through it the long way, though, and see if you maybe found the shortcut. Take x multiplied by x, you get x to the power of 2. X multiplied by 12, you get 12x there. Then take negative 12, multiplied by x, you get a minus 12x. And then the last one here, negative 12 multiplied by positive 12, you get a negative 144. Now, at this point, once again, take a look at what you've got in the middle, which it looks like I'm missing an x somewhere. I'm missing an x right here. Should have been a plus 12x. I need to take positive 12x minus 12x, which, hey, guess what? adds to be 0. Bring down your x squared. Bring down your minus 144, which was your last term. And here is your final answer, x squared minus 144. All right, so if you think you found the shortcut, check yourself. Did you get it right? Here's your one last chance to check and see if you figured it out. So on this last one, where you have x minus 4 multiplied by, or x minus 4 multiply, let's change this to an a, or to an x. So instead of having a there, I think there was just a typo. Let's change it to an x real quick. That way we have x minus 4x plus 4. Okay, so we're going to take x multiplied by x, we get x squared. X multiplied by 4, you get a positive 4x. And then for your second term, take negative 4 multiplied by x, you get a negative 4x. And then negative 4 multiplied by positive 4, you get a negative 16. And then take a look at your middle terms. Positive 4x minus 4x adds to be 0. Still have your x squared, that was your first term. Still have your minus 16, which was your last term, x squared minus 16. At this point, hopefully you've been able to spot kind of the trick in the shortcut. Here's what I want for you to do, is where it says, can you recognize the pattern? I want you to write down what you think the pattern would be. Now, I'm not going to share that with you today. We'll talk about it maybe later if we need to, but I'm hoping that by now you've seen what the pattern is and can write that down. Then, when you're done with that, I want you to try to generalize what a minus b multiplied by a plus b would be. So take this expression down here and kind of give me a general, here is what this would look like if I multiply them together. Alright, at this point we're going to look kind of for our second special case, and so we're going to start with multiplying the following binomials. We start with x plus 5, then x plus 4, x plus 4, x plus 3, x plus 3, 2x plus 1, 2x plus 1. First, just look and see how they're all similar. They all kind of have the same kind of stuff going on in each of them. Look and see how they're similar, and then I want you to go ahead, like you did before, multiply your way through all of them first. Then go ahead, unpause the video, and I'll show you what I got for my answers. So pause the video now, see what you get when you distribute. Alright, here we go. So we are going to start with x plus 5 multiplied by x plus 5. When we go to distribute there, first take x multiplied by x and you get x to the power of 2. Then taking x multiplied by 5, you get a plus 5x. Next, take your positive 5 now, multiply by x, you get a positive 5x. And then positive 5 multiplied by positive 5, you get a plus 25. Now, be careful. Take a look at the two terms you're going to combine in the middle. It's not 5x minus 5x, it's 5x plus 5x. So you would do 5 plus 5 actually gives you 10x, not 0 like it did before. Still bring down everything else, so bring down your first term, which was x squared. Bring down your last term, which was a positive 25. So for this one, you would have x squared plus 10x plus 25 for your final answer. Alright, let's work one more together and see if we can't spot the pattern here. So let's take a look at x plus 4 multiplied by x plus 4, and I'll try to fit them side by side here for you. First, take x multiplied by x, you get x squared. Then take x multiplied by 4, you get a positive 4x. Next, take your positive 4 in the middle. Multiply by x, you get a plus 4x. And then positive 4 multiplied by 4, you get a plus 16. At this point, once again, take a look at those two terms in the middle. You've got 4x plus 4x. They do not add to be 0, they add to be 8x. And then copy down your first term, which was x squared. Copy down your last term, which was a plus 16. So for this one, final answer is x squared plus 8x plus 16. Alright, if you think that you have seen a pattern on this next one, check to see if it works. So, next one we're going to look at here is x plus 3 multiplied by x plus 3. As we take a look at this one, first take x multiplied by x, you get x squared. Then take x multiplied by 3, you get positive 3x. Alright, distributing your second term, which is a positive 3. Multiplied by x, you get a positive 3x. and then positive 3 multiplied by positive 3, you get a positive 9. At this point, once again, look at those two terms in the middle. 3 plus 3 tells you you have a positive 6x in the middle. Then bring down your first term, which was x squared. Bring down your last term, which was a plus 9. Here is your final answer. All right. So, look and see. Have you found the pattern yet? If you have, maybe start to write that down. But at this point, we are going to go ahead and look at this last example. So if you think you know the pattern, double check, make sure it actually works here. All right, so where you see 2x plus 1 multiplied by 2x plus 1. First, take 2x, multiply by 2x. Now be careful. Multiply the numbers in front first. 2 multiplied by 2 gives you 4. Then multiply your variables. X multiplied by x, you get x squared. Next, 2x multiplied by 1, you get a plus 2x. Remember, anything multiplied by 1 is just that same expression. So then really nothing's going to change when we multiply everything by this positive 1. You take positive 1 multiplied by 2x is a plus 2x. And then a positive 1 multiplied by 1 is a plus 1. At this point, take a look at your two middle terms here, where you have 2x plus 2x gives you 4x. Then bring down your first term, which was 4x squared. Bring down your last term, which was a positive 1. Here's your final answer, 4x squared plus 4x plus 1. So, on this one, maybe you saw your pattern didn't quite hold. Maybe you need to go back and re-look at it. Go ahead, look at all of them, set them all up side by side, see if you can't figure out how each one works. If you recognize the pattern, go ahead and write that down in this blank here. And then if you can generalize what a plus b multiplied by a plus b would be, write your answer down here. At this point, this is the end of the video. We will talk about this a little bit more on Monday. If you haven't found the pattern yet, keep looking. Gotta find that pattern. It's going to be important for the rest of the semester. At this point though, if you are done with the notes and you're done with the video, here's what I would like for you to do. On the cart, the blue card over there, there should be your homework assignment. Your homework is going to be worksheet 7.6, which is multiplying polynomials with special cases. That's kind of what we looked at today, was we looked at multiplying polynomials with special cases. That is going to be your homework. It's going to be due on Monday. So when I see you again on Monday, that is what I will have you turn into me. There will be a homework quiz over that when I am back. So on Monday, plan for homework quiz. Just as a reminder, keep in mind some stuff that's coming up. You also do have a test coming up on block day. So make sure that you're getting caught up in your notes. Make sure that you're ready to go so that on block day you are ready to take that test. At this point, that's all I've got for you. Have a great rest of your Friday. Get that homework done so that you don't have homework over the weekend, and I will see you back on Monday.